So the next topic we're going to talk about on our review day here is inverses. So once you guys mastered domain and ranges, then we started talking about inverses and what would happen when we find the inverse of a function. So there's a couple ways to think about it. One way to think about inverses was if I had a graph of some sort of function that looked like this. I could find the inverse of it kind of like graphically by cheating a little bit, because inverses will always be a reflection over the line y equals x. So maybe this point right here would go, this is like 0, I don't know, 3. So remember, you would just switch the x's and the y's. So this point would go to 3, 0. Maybe this point right here was -2, 1. So then this point would go to 1, -2. And then you just kind of sketch the same shape. And remember, they would line up on each other. Now this inverse, this right here is a function. So we'll call that a function right there using function notation. But when I find the inverse of it, see how it doesn't pass the vertical line test anymore? So this is not a function. We call it f inverse of x, but this one is really just a relation between two numbers. It's really not a function. And that's okay. We can still work with it, but your calculator can't graph it because it can only graph functions. So graphically, that's what's happening. And then remember, if the domain of this graph over here, well, we know that that's a parabola, so the domain of that is all real numbers, and the range, all I have to do is find the smallest y value, so that would be y is greater than or equal to 1. Do you guys remember what happened with the domain and range? You just take them, and because basically we're just switching all the x and the y values here, you just switch the domain and the range for your relation over here. So for the inverse then, the domain would be x is greater than or equal to 1, and the range would be all real numbers. And basically all you had to do is just flip them. So that was kind of fun. But then actually the more fun part for everybody, this is one of your favorite things, was actually finding inverses. So if I gave you the equation, g of x is equal to the square root of, let's say, x minus 5. So I have a square root graph. So I always like to think about things and graph them first so I'm on the right track. So I know what square root graphs looks like. This one, in order to graph it, I'm going to think about the domain. So let's see, this has to be greater than or equal to 0. So x minus 5 is greater than or equal to 0. So x is greater than or equal to 5. So that means that this is going to start at 5, and then it just does the same square root shape that we're used to. Something like that. So here's your domain, and then your range would be y is greater than or equal to 0. Now it's really important that you understand the domain and range of this graph, because when you find the inverse, it's going to look a little bit different than this. So if I'm thinking about this graphically, what it's going to look like, it's basically, instead of moving 5 along the x-axis, it's going to go 5 along the y-axis, and then hook up like that, like that. So here this would be kind of like a sideways parabola thing, and then this is kind of like half of a parabola. So keep in mind when I say half of a parabola, it's important. So now in order to find the inverse, you do two things. Switch the x and the y values. So remember, this g of x really is a disguise for y. And so I'm going to switch the x and the y values. So x is equal to the square root of y minus 5. So first step. And then the last step is to just solve for y. So remember how you would get rid of a square root of an equation like this. All you have to do is just square both sides. So I would say, all right, I'll square both sides. And then x squared is equal to y minus 5. And then the last step is to just add 5 to both sides. So y is equal to x squared plus 5. So there you go. So these two functions right here are inverses. Well, that's really great, but you're looking at this and you're thinking, this is really a parabola. We were just talking about parabolas. But when I graphed it over there, it's only half of it. And that's because, remember, these domain and ranges are just going to come over here and switch. So normally, the domain of this parabola would be all real numbers, but because it's the inverse of this function, it has baggage that it has to carry along with it. We all know baggage, right? It's not normally a good thing. So instead of being all real numbers, now x is restricted to only being greater than or equal to 0 for your domain. And then the y values would be y is greater than or equal to 5 for the range. So when you look at the picture of that, it makes sense. Oh yeah, all the x values can only be bigger than 5, just the right-hand side of the parabola, and all the y values are greater than or equal to 0. X is bigger than 0, y greater than 5. So don't think that this one can have a domain of all real numbers, because it started off with only this part in the beginning.